Hey guys, so this is this week's video for our grind. I'll just quickly run through the questions that we did, and like always, if I've forgotten any, let me know. And if you have any other questions, I can get back to you. So we started off last time, just finishing off our booklet on the line. So this will only take 2 seconds, and then we went on to exam papers. And Sophia, you asked me, gave me a question as well, and I'll run through that at the end. So yeah, let's get started. So it says, prove the point 29 lies on the line in part 3 above, y equals 2x plus 5. So to prove a point lies on a line, all you have to do is sub in the points and see if it equals to 0. So here we can see that x is equal to 2 and y is equal to 9. So we're going to say 9 is equal to 2 times 2 plus 5. And you can see that 9 is equal to 9, 0 is equal to 0. So the point on the line. So part 2 says find any other 2 points that sit on the line. Well, our line is going to be 2 times x plus 5. So an easy one we can do is just set x equal to 0 and see where it crosses the y-axis. So if we do 2 times 0 plus 5, it's going to be y equal to 5. So we know 0.05 is on the line. What we can do as well is just set x equal to something and see what the y is, and we know that's going to be on the line as well. So if we set x equal to minus 2, then y is going to be 2 times minus 2 plus 5, so it's going to be minus 4 plus 5, it's equal to 1, so y is going to be 1, so we know the point minus 2, 1 is on the line as well. So we don't really have to go back and check these because we can already see that, like, we subbed in 0 for x, and if we get rid of this line here and we sub in 5 for y, we're just going to get 5 equals 5, so that's 0 equals 0. And kind of same thing here, we subbed in minus 2 for x, and if we get rid of this line here, we sub in 1 for y, we're going to get 1 equals 1, so 0 equals 0. So yeah, those points are on the line. So part 2 says calculate the slope between these 2 points. So your slope is just y2 minus y1 over x2 minus x1. So for our points, let's say that's x1, y1, that's x2, y2. That's going to be 1 minus 5 over minus 2 minus 0. So it's going to be minus 4 over minus 2. So it's going to be 2. And what we were saying during the grind is you can calculate it this way, or we can just see that if we go back to our line up here, our number in front of our x is going to be our slope of the line. So if these 2 points are on the line, 0, 5 and minus 2, 1, they're on the line. Minus 2, 1, just make some space. If those are on the line and we get the slope between these 2 points, then that's going to be the slope for the whole line because it doesn't change. And we can easily get the slope of our line by just looking at the number in front of our x. So that's kind of the takeaway I want you to get away from this question. You can kind of guess what my takeaway here is of this question. But so let's do it anyway. So let's calculate the y-intercept of the line. So our line was y equals 2x plus 5. Y-intercept is where x equals to 0. So because if we draw it and our line is like this, say, we don't move any left or right x. So our x is equal to 0, and we're going to find out what our y is. So let's set x equal to 0. We've already done this in the last question. This was our point. So y equals to 5. This is our point 0, 5. And we can, going back to what we were saying before, we can easily see that our y-intercept is just y equal to 5. So if you have your line y equals mx plus c, your slope is going to be the m, and your y-intercept is going to be the c. And part 3 says calculate the x-intercept of the line. So there's no real cheat for this one. You just have to do kind of the opposite of what you're doing for the y-intercept. So for the y-intercept, let's pretend this is the line. We didn't move any x or any x right or any x left, and we just went up to see what our y value was. for the same thing, we have no up or down y. Our y is going to be e0. So if we set y equals 0 and see what x is equal to, then we're going to get our value for x. Plus 5. So we're going to bring this minus 5 over. So it's minus 5 equals 2x. And so x is going to be minus 5 over 2. So our point is going to be minus 5 over 2, 0. So that's our x-intercept. Moving on then, find the equation of a line that goes to the point 0, 3 with a slope of 2. So we can do this the hard way. So we can say we can get our slope and we can get a point, and you can do a lot of things the hard way. Oh yeah, you were doing y minus y1 equals m times x minus x1. But like we were saying before, it's just y equals mx plus c. And we know that's our y-intercept because x is 0. So our line is just going to be with a slope of 2. So m is 2, x plus y is 3. So that's our line. So it goes, we have a y-intercept of 3, and we have a slope of 2. And that's it. That's your line. Moving on then, find the equation of a line that goes to the point 1, 2 with a slope of 5. So this time, yeah, you would have to use y minus y1 equals m times x minus x1. And the reason you're going to have to use this is because you don't know the y-intercept. If you knew the y-intercept, if x was equal to 0 here instead of 1, we could do it like we did above, where we just wrote them in. But here we have a point and a slope, so we're going to use this function. So we're going to say y minus our y is going to be 2 equal to our m is going to be 5, and our x is going to be 1. So that's that's going to be y equals to 5x minus 5 plus 2. So y is equal to 5x minus 3. And so that's our equation for the line. The reason I put these questions in is to just kind of show you that y equals mx plus c and y minus y1 equals m times x minus x1 are both just the same equation. But when you have the y-intercept, your x is going to be 0 here, and this y1 is going to come across. So if I rearrange this, x times our x here is 0, and we're going to bring across our y1. So you can see that this is the same thing as this. Your y1 is your c. Yep. So next question, graph the lines y equals 3x plus 3. So that's good. We know our slope. We know our y-intercept. So we just pick out our y-intercept. That's 0, 3. And we have a slope of positive 3. And we just draw your line. That's it, really. Y equals 2x plus 5. We're going to pick out, same thing, we're going to pick out our y-intercept. And we're going to have a slope of 2. So this slope isn't as steep as our 3. So let's do that kind of this way. And you can see if we extend these on, they're going to cross at some point. It doesn't have to be too accurate. But yeah. Oh yeah, next question, calculate where the lines cross. So we could see here, if we had drawn it really accurate, we could drop this down and get the coordinates of this point. So let's say it's AB. But we don't really want to do that. That would take time. But if we know that this is our equation for y equals 3x plus 3, and this is our equation for y equals 2x plus 5, we can see that where they cross, the two equations are equal to each other. So we can see that here y is equal to 3x plus 3 and y is equal to 2x plus 5. So we can set y equal to y. So that's 3x plus 3 equal to 2x plus 5. So then we can find x. So that's 3x minus 2x equals 5 minus 3. So that's x equals 2. And we can go back and get y. So y equals 2x plus 5. Y equals 2 times 2 plus 5. 4 plus 5. Y equals 9. So the point where they cross is going to be the point 2, 9, and that's this point here. So what I did was let the equations equal to each other, because y is equal to y at this point, and I subbed in my values for y. So y was this and y was this. If it helps, you can say y1 and y2. So y1 is equal to y2 at this point, and we know that y1 is this, and we know that y2 is this. And then you can find x and sub it back into either y1 or y2 to get y, and those are going to be equal to each other, and you're going to get your point of intersection. But yeah, that was the just finishing off the booklet we were doing. Main takeaways of this section was writing your line in the form y equals mx plus c, or y minus y1 equals m times x minus x1. So they're the same thing, really. If you have the y-intercept, you can just write it straight away. If not, you can plug it into, and you have a slope, you can plug it into that equation and get your line. And find calculating where two lines cross. That's also your main takeaway, as we'll see in the next question. But yeah, let's move on. So next question. So this question is an exam question that's basically here to show you that functions and algebra and the line and all these things can kind of interlink and be connected, and they can give it all to you in the same question. But let's jump right in. Yeah, it says, so the graph of a cubic function f of x cuts the x-axis at -3, -1, and 2, and the y-axis at 0, -6 as shown. Verify that f of x can be written as x squared plus 2x squared minus 5x minus 5. Okay, so that's very straightforward. We know it crosses the x-axis here, here, and here. So we know those are going to be our roots. So f is going to be, or x is going to be -3, x is going to be -1, and x is going to be 2. And if we bring each of these across the other side, we can turn them into factors. So that's x plus 3, x plus 1, and x minus 2. And we know factors multiplied together will give us the function. So that's x plus 3 times x plus 1 times x minus 2. So yeah, let's do that quickly. So that's x squared plus 3x plus x plus 3. And all that's times x minus 2. So that's x squared plus 4x plus 3 times x minus 2. And that's going to be equal to x cubed plus 4x squared plus 3x minus 2x squared minus 8x minus 6. And if we keep going on in space, we're going to group our like terms together. So you see we have two x squareds and two x's. So we'll just write those next to each other. Plus 4x squared minus 2x squared plus 3x minus 8x minus 6. So that's x cubed plus 2x squared minus 5x minus 6. And you can see that that's exactly what they wanted in the question. Just a note, if this here was 8, say, or 12, let's say it was 12, then because we know it crosses at -6, we'd need to multiply everything by a half. So we'd need to multiply all of what we just got by a half. So blah, blah, blah. Because this, when x is equal to 0, you're going to get a value of 6, and that's what we have up here, 0, 6. But that didn't happen in this question. I think I've given you out a question that we'll get to next week that will focus on that. So you multiply all out your function, but you get a different number down here, and you're going to need to correct that. But we'll get to that when it comes to it. So part 2, or B part 1, the graph of the function g of x is equal to -2x minus 6 intersects the graph of the function f of x above. Let f of x equals g of x and solve the resulting equation to find the coordinates of the points where the graphs of f of x and g of x intersect. So they've given you a hint here. They say f of x is equal to g of x, but even if they didn't, we know that, like we were saying before in our booklet, when two lines were equal to each other, the point was the same. So that's how you get the point of intersection. But yeah, let's do it. So g of x is equal to -2x minus 6, and we know that f of x above was x cubed plus 2x squared minus 5x minus 6. So let's let those equal to each other. Minus 2x minus 6 is equal to x cubed plus 2x squared minus 5x minus 6. We can see the 6's are going to cancel straight away. And we're going to get a cubic in the form x cubed plus 2x squared minus 3x equal to 0. We can take out our x squared plus 2x minus 3 equal to 0. So the only way these two things multiplied are equal to 0 is if each of them are equal to 0. So it's x equal to 0 and x squared minus 2x minus 3 is equal to 0. And we can see that this, we can factorize this. So x 3, 1, minus plus. So x minus 3, x plus 1. So this is equal to x minus 3 times x minus 1 equal to 0. And kind of same deal, if both of these multiply together equal to 0, then both of them have to be equal to 0, or at least one of them has to be equal to 0. So we take two cases. X minus 3 equal to 0 and x minus 1 equal to 0. So x equals 3 and x equals 1. So we might think we're done, but we're not. We have to go back and get each y value for each x. So we know x is equal to 0, x is equal to 3, and x equal to 1 are all the x values of our points of intersection. But let's sub them back in and get our y values. So we can take our pick. We have two functions for the y value at this point because they're both equal to the same thing. And we can see that this one is much easier than this one. So let's use this one. So we're going to sub in x is equal to 0 minus 6. So y, or g of x, same thing, is equal to minus 2 times 0 minus 6. So y is equal to minus 6. So one point of intersection is 0 minus 6. Let's do the same thing with 3 that we found. So that's minus 6 minus 6. So y is equal to 0. So that point is 3, 0. And the same thing with x is equal to 1. So that's minus 2 minus 6. So that's minus 8. So our point here is 1 minus 8. So this is what you would have to write to get full marks in this question. You need to write your x value and your y value in the form of a point. And these are three values of our points of intersection. So it's 3 points where the two curves cross each other. And we're going to see that now in a second because it says draw the graph of the function g of x equals minus 2x minus 6 on the diagram above. So this is our diagram. We're going to draw g of x. Things like this, it doesn't really matter. Like we can just draw the line and then write the points. So we'll just kind of get a rough idea where they are. So 0 minus 6, so this is here. 3, 0 is going to be somewhere here. Sorry, no, that's not 3, 0. That's 3 minus 12. And yeah, that's right. That's minus 8. So it'll be 1 minus 8. It'll be somewhere here. And sorry, that's see, this is, go back and check. So I made a mistake. That's x plus 3 equals 0. So that's x equals minus 3, and that's obviously going to change up here. I knew it was equal to 0, so that's plus 6 minus 6, that's 0, so that's minus 3, 0. So that's that point here, this point here, and you can, I think I actually have a ruler, if I can get it. Draw, it doesn't matter. But what you would do here is kind of get an idea of where they all are, so they're all kind of in this spot, and then just draw a line that connects them all. See, I've missed there because I don't have a ruler, but oh yeah, that'll work. So draw your line like that, and then just label the points 0 minus 6, and whatever points they were. So draw the line first, then write your coordinates, because if you draw the coordinates and then try connect them all, and if you've gotten the coordinates in slightly the wrong place, your lines or your dots might not connect, and it just creates a whole big mess. So just draw the line, bang it down. It doesn't really matter. Things like this, the only small marks anyway. If they see that you have the line and the points labeled, they're going to give you full marks. But yeah, that's the next question. So next question, again similar. This question is kind of just to show you that algebra and the line are kind of connected. And we did this question before. It was simultaneous equations, because you can see there are two equations on top of each other. Um, but now we can see this in a new context, because it's two lines, a line and a curve C, have points of intersection, and we're trying to find the points of intersection. So we can see this in a new context because when we were doing simultaneous equations before, we can see that we couldn't cancel anything because this was x squared and this was y squared. So what we did was we got the y up here on its own, and then subbed it in. And that's the exact same thing you're doing when what we did before, when we let the two lines equal to each other. So let's do that. So we know that x minus 3y minus 1 is equal to 0, and x squared plus 4y squared is equal to 1. We're going to take our easy one and get y on its own. So that's minus 3y equals to minus x plus 1. So that's 3y equal to x minus 1. So that's y equal to x minus 1 over 3. And we're going to sub it into this one here. So that's x squared plus 4 times x minus 1 over 3 to b squared equals 1. X squared plus 4 times x squared over 9 minus 2x plus 1 all over 9. So what we're doing here is we can square the top and square the bottom. So that's this squared over 3 squared. And then that's all equal to 1. So we can multiply in our 4, x squared equals, x squared plus 4x squared over 9 minus 8x over 9 plus 4 over 9 is equal to 1. So that's 13x squared over 9 minus 8x over 9 plus 4 over 9 minus 1 equal to 0. 13x squared 9 minus 8x over 9 plus, that's 4 over 9 minus 9 over 9. So that's going to be minus 5 over 9. 13x squared over 9. We can multiply everything by 9, so it's 13x squared minus 8x minus 5. Then we can factorize. So 13, 1, 5, 1. That's going to be 13x. So it's going to be plus minus 13x plus 5 times x minus 1. 13x squared minus 5x. So plus 5x minus 13x. Yeah. Sorry, I was just checking how that works. So that's equal to 0. So the only way that's equal to 0 if both of them are equal to 0. So x equals 5 over 13 and x equals 1. And now we're going to go back and find our y. So we have two, like we were finding our points of intersection. We have our values for x. We need to go back and get y. So we're going to use our easy equation for y, and we have it here. Y equals x minus 1 over 3. So y equals x minus 1 over 3, and we can sub in 5 over 13. So that's 5 over 13 minus 1, and that's all over 3. So that's 5 over 13 minus 13 over 13 all over 3. That's going to be 8 over 13 over 3 over 1. That's going to be 8 over 3 times 13. 8 over 9, 39. And same thing, y equals x minus 1 over 3, 1 minus 1 over 3, y equals 0. So our points are going to be 5 over 13 and 8 over 39 and 1, 0. So those are points of intersection. If, like, because these are such weird numbers, you might go back and check if you had more time to see if they satisfy the equations. Just basically go back and check your points always. But if you're confident, you can leave it there. I might have, these points don't sound familiar, so I might have made a numerical slip. If I have, let me know, and I can always revisit it. But as long as you know the technique that we're using, there should be no problems. So this question was to show you that what we were doing before, simultaneous equations and algebra, that kind of thing, all have kind of links with coordinate geometry. So yeah, on to the next question. So on to the next question. This question is an exam question, and it's basically to do. I picked it because I wanted to show you two ways of using the shortest perpendicular distance. So we can see here that any kind of picture like that looks like this, you can see that's perpendicular and that's perpendicular. Alarm bells are going to go off in your head that you should use the shortest perpendicular distance formula. But the reason I wanted to pick this question is because you can do it without using the formula. And I think it's just really important to show that you can do coordinate geometry questions and lots of questions in maths lots of different ways, so that if you forget the formula, if you can't find it in the log tables, that kind of thing, you can still figure out the question. Like it's not the be all and end all. Formulas aren't necessary for any type of question. You can always figure it out. But yeah, let's jump right in. So first one is easy. It says verify that a equal to minus 2, 1 is on M. So we know when we're verifying something is on M, we're going to sub it in. So that's our x, that's our y, and we're going to see it equal to 0. So M we can see is 2x plus 3y plus 1 equal to 0. We're going to sub in 2 times minus 2 plus 3 times 1 plus 1 equal to 0. So that's minus 4 plus 3 plus 1 equal to 0. And you can see that that's 0 equal to 0. So that's verifying that A is on the point. So next one, find the coordinates of B and the point on the line closest to A as shown. So one way to do this is to, we know the coordinate for A and we know the equation for the line N. So we can get the shortest perpendicular distance from A to that line, and then get the distance between A and B and set it equal to this distance. But I want to do it the other way. It gave us a bit of trouble during the grind. And we never actually got an answer, but I'll go through it slowly here, just to show that you can do it any way you want. As long as your logic is sound, you can do the question any way you want. So find the coordinates of B, and so we want to find the coordinates. It helps if we work backwards. So we want to find some kind of x and y at B, and it's also on the intersection of this line and this line. So the point B lies on this the line AB, and it also lies on the line M. Well, we know how to do that. If we want to find a point of intersection between two lines, we need to have an equation for both of the lines, set them equal to each other, and then we're going to get our point of intersection. Basically, what's stopping us from doing that is we don't have an equation for AB. It wasn't given to us in the question. But what we do have is the point A and the equation for M, and we can use that to get an equation for AB. So then we have an equation for AB, we have an equation for M, we can find their intersection and get the points for B. So let's do that. So let's write out, so we worked all the way backwards, and basically, so we're going to be working first with the point A and the line M. So let's write those out. So M is going to be 2x plus 3y plus 1 equal to 0. And basically what we're going to want is we're going to want the slope. And we can see that these are perpendicular, so this slope is going to be the exact opposite, even minus sign of our slope. So let's rewrite M like we like it. So y equals mx plus c. So let's bring the x and the 1 over to this side. So that's minus 2x minus 1. And then divide everything by 3. So it's minus 2 over 3x minus 1/3. So this is our equation for m. We know that this is y equals mx plus c. So we know m is going to be minus 2/3, and our y-intercept is going to be minus 1/3. So m is equal to minus 2/3. So that our slope of the line m is going to be minus 2 over 3. And we know if we want the slope exactly perpendicular to it, we're going to want to flip it upside down and change the sign. So the slope of AB is going to be 3 over 2. And we change the sign, 3 over 2. Another way, I don't know if your teacher showed you this, to check this is when two slopes are perpendicular to each other, and them multiplied together should always give you minus 1. And you can see that that 3 will go, that 2 will go, and you're left with minus 1. So that's another way to check that your lines are perpendicular, or your slopes are perpendicular, sorry. Okay, so we have a slope for m, and we have a point for m, so that's all we need. We can use our formula y equals y minus y1 times m times x minus x1. Well, our point A is going to be minus 2, 1. That was given to us up here. So we're going to sub this in. So that's y minus 1 equals m, and our m is going to be 3 over 2. We figured that out. 3 over 2 times x minus 2, so that's x plus 2. So our equation for the line AB is going to be y equals 3 over 2x plus 3 plus 1. So that's going to be, I just brought the 1 across and multiplied the 3 over 2 into 2. So that's 3 over 2x plus 4. So same thing, that's our m, that's our c. So we know the slope of our line, like we were saying before, is 3 over 2. So now, we're definitely on the right track. We have the slope for the line AB, and they gave us the slope for the line N, and now we just got to find their intersection and get the coordinates for the point B. So they gave us N was 2x plus 3y minus 51 equal to 0. Let me just check that's right. 2x plus 3y minus 51 equal to 0. Yep. So what we were doing before in our booklets were we had two lines in the form y equals mx plus c. Let's give these some kind of values, 3 plus 7 or something, and y equals 4x plus 5. Because these y's were on their own, we could let these two equations equal each other and then get x and then sub back in and get y. So let's do that. Alternatively, because we have the y here, you could sub that all of this here into our y, and it would work out the same way, exact same solutions, but I just think this way is easier. So let's get, in our equation for n, let's get y on its own. Y equals minus 2x plus 51, and y is equal to minus 2 over 3x plus 51 over 3. And now we have two equations where y is on its own, and we can set them equal to each other. So 3 over 2x plus 4 is equal to minus 2 over 3x plus 51 over 3. So I'm going to bring this x this way, and I'm going to bring that 4 that way. So that's 3 over 2x plus 2 over 3x is equal to 51 over 3 minus 4. So if we cross multiply, because our denominators are different, we're going to have to cross multiply to get them equal to each other. So I'm going to multiply this one by 3, and then this one by 2. And all that's going to be equal to them multiplied together. Same thing over here. I can multiply above and below by 3 to get 3 on the bottom, so I can add them. So this is going to be the same as 4 times 2 is 3 over 3. So that's 51 over 3 minus 12 over 3 is the exact same as 51 over 3 minus 4. So now this is 9x plus 4x over 6 is equal to 51 minus 12 is 39 over 3. This is 13x over 6 is equal to 39 over 3, almost there. So now we can multiply by 6 and then divide by 13. So x is going to be 39 times 6 over 3 times 13. That's going to be 39 times 6 over 39. We can divide up and below by 39, and we're going to get x is equal to 6. So kind of same story like we've been doing the whole time. We have a value for x, but we need to go back and get a value for y. And we can use any of these here. So let me just even copy this. So we can use any of the two equations that we used. So let's sub back in 3 over 2 times 6 plus 4. We can divide that 2 in, so that's just 3. So 3 times 3 is 9 plus 4, so that's 13. So y is equal to 13. So the point of intersection, let's go all the way back up, of the line AB and the line N, this point here, B, is going to be 6, 13. And that's the answer. Find the coordinates of B, 6, 13. Now, like I was saying before, you can use the perpendicular distance formula, and I will do that next week. I wanted to show you that you can do it any way you want, and we weren't too familiar with the perpendicular distance formula, so I wanted to let you figure that out a bit before we tackled it. But yeah, so this is your question. On to the next question. So on to the last question. This is a question that Yusufia wanted me to answer. Yeah, it's no trouble. Any other questions like that, just send me a text during the week and I can include it in that week's video. But yeah, let's jump right into it. So it says the line RS cuts the x-axis at the point OR and the y-axis at the point 0, 10 as shown. The area of the triangle ORS, where the O is the origin, is 125. So the area here, ROS, is 125 over 3. So find the coordinates of OR. So what we're going to do here is use the information that they've given us. So we know the area is going to be half the base times the height, and that's going to be 125 over 3. And we have this point here, 0, 10. So if this point here is 0, 10, then the height of this triangle is going to be 10 units, and the base is going to be just the distance between O and OR. So we can plug these into our, sorry, let me not get rid of that. And let me make this pen a bit smaller. We can plug that into our equation. So our base, we said, was just OR to O, and our height was 10. That's going to be 125 over 3. So then we can just cross multiply 2, multiply by 2 and divide by 10. So we know that OR is going to be 125 times 2 over 10 times 3. That 2 is going to cancel with that 5. So and that 5 is going to cancel with that 125. And 125 divided by 5 is, I should know that, but it's late. 25, yeah. So that's 25 over 3. So OR is 25 over 3. And that's the distance between OR, so we know our distance formula. So let's call this coordinates xy. And so that's x minus 0 squared plus y minus 0 squared is equal to 25 over 3. I'm running out of space, so let me just jump back over to this side. So x minus 0 is just x, so this is, and y minus 0 is just y, so it's x squared plus y squared is equal to 25 over 3. We know because it sits on the x-axis, we can even get rid of the x-coordinate, or the y-coordinate, sorry, because we haven't gone up or down any y. We've only gone backwards an x. So we know our y is going to be equal to 0. So we can say x squared is equal to 25 over 3. And we know that the square root will just cancel with the square, and we're left with x equals 25 over 3, y is equal to 0. So our point is going to be 25 over 3 and 0. Yeah. So on to the next part. Sorry, I just forgotten a bit there. Yeah. So, and this came from me cancelling, which I really shouldn't have done. It doesn't matter, but let's do it anyway. So let's multiply this out. So we're going to square both sides. So that's x squared is equal to 25 over 3 squared, and then we're going to square root. So we know if we square root, we're going to get plus or minus. And there we go, we're just running out of space. So I'll rewrite this bigger. So x is equal to plus or minus the square root of 25 over 3 squared. Now this is just a number. These will cancel like I was saying before, but we have to remember the plus or minus. So x is either equal to whatever number this is, or it's equal to minus whatever number that is. And we know from our graph that it's going to be minus because we've gone backwards. So that's just a little point to watch out for. Basically, when you're cancelling your square roots, sometimes you can do it as long as you're careful, which I wasn't here, that just remember your pluses and minuses. So we know that x is going to be minus 25 over 3 and y is going to be 0. So our point is minus 25 over 3 and 0. So that's part 1 done. Part 2, show the point e minus 4, minus 5, 4 is on the line, or s. Okay, so how are we going to do that? Basically, we know when we're subbing in points, we're going to sub it into the equation of the line and let c that 0 equals 0. But here we don't have an equation for or s, but let's go ahead and find one. Basically, what we can do is we have 2 points, and we can basically get the slope and then use the slope and the point, our y minus y1 equals m times x minus x1. We could do that to find the equation of our line. So we know this point is 25 over 3, 0, and this point is 0, 10. So let's find our slope. M is going to be y2 minus y1 over x2 minus x1. So that's going to be, let's say that's y2, so let's say this one's y2. So that's 10 minus 0 over 0 minus minus 25 over 3. So that's 10 over 25 over 3, so that's 10 over 1 over 25 over 3. So that's going to be, this one goes all the way to the top, and this one only goes halfway, so that's 3 times 10 over 25 times 1, so that's 30 over 25. So our slope is going to be 30 over 25, and we have, let's just use our point 0, 10, so we can put this into our equation. Y minus y1 equals m times x minus x1. So it's going to be y minus 10 is equal to 30 over 25 times x minus 0. So y is going to be 30 over 25x plus 10. And basically we want to show that e is equal minus 5, 4 is on this line, so we're going to sub in everywhere we see y, where it's going to be 4, and x is going to be minus 5. So it's going to be 4 equals, I have a bit of space up here, let me do it. 4 equals 30 times 25 times x was minus 5 plus 10. Our 5 is going to cancel with our 25, and we're going to be left with 5 down here. And our 5 can even go into our 30, and that's going to be equal to 6. So 4 is equal to minus 6, don't forget that minus there, plus 10. So 4 is going to be equal to 4, therefore 0 is equal to 0. So that shows that our point minus 5, 4 is on the line or s. So the last part was, I think, the part that gave you trouble, Sophia. It says a second line, y equals mx plus c, where m and c are positive constants, passes through the point E, and again makes a triangle of area 125 over 3 with the axes. Find the value of m and the value of c. Basically what this is going to look like is it'll probably pass through it that way, or some kind of way. It doesn't really matter what slope it is, but as long as we know that E is on the line and the area, whatever area it is going to be 25 over 3. So yeah, let's hop to it. So we know the area is going to be 125 over 3, and that's going to be half our base times our height. Well, how are we going to do that? Same thing we can do here is we can find where it crosses both the x and the y axis. So let's do that. So so our equation is y equals mx plus c. Where does it where does it cross the y-axis? We know if it's written like this, it's going to cross the y-axis at c. So our y-intercept is going to be equal to c, and our x-intercept is going to happen when we let y equal to 0, like we did here. So you don't move up or down any y, and you go across to an x. So we're going to say y equals 0, and that's going to be mx plus c. So if we bring this c across, that's going to be minus c equals mx, and we're going to divide by m. So minus c over m is going to be equal to x. So the coordinate for our y-intercept is going to be 0, c, and the coordinate for our x-intercept is going to be minus c over m, 0. So basically, what's going on, let me clean some of this up, is, pretend this goes this way, it's going to look like this kind of, and these are going to be our 2 points. So this was 0, c, and this was minus c over m, 0. And so now we know that this area here is going to be 125 over 3, and we're going to use that. Same thing we were doing before, get the distance between there and the distance between there, and do the half the base times the height. So let's do that. Let me clear up some space. So yeah, we already have it up here. So that's a half times the distance between minus c over n minus 0 squared plus 0 minus 0 squared. And then that's going to be times our height, same as last before, like this time is 10, this time is just going to be c. So that's going to be a half times minus c over m squared times c. That's going to be a half times square the top, square the bottom. That's going to be square root of c squared over m squared times c. That's going to be a half times, basically these are all going to cancel, and you're going to be left with c over m times c. So that's going to be a half c squared over m is equal to 125 over 3. So we see we have two kind of unknowns here. Let's just split them up just so they're not linked. So probably let's get m on its own because the c is squared. So let's multiply m across and 3 across like this, and then probably divide by 125. So let's first multiply by m to make it 125 over 3. So a half c squared is going to be 125 m over 3. Then we can multiply by 3, so that's 3 over 2 c squared is going to be 125 over m. And so m is going to be 3 over 2 times 125 c squared. And that's going to be 3 times 10, 4, 5, 2, 5, 0 c squared. Okay, so we have m equals 3 over 250 c squared. We see we have two unknowns, and basically the reason we have two unknowns is because we only used one bit of information. We only used that the area was equal to 125 over 3. And so how we're going to get rid of either one of these unknowns is we're going to use the other bit of information, is that it passes through the point E. So we know the point E, which we got the coordinates for, are in this point. So we know let's kind of do a little aside here. Our equation was mx plus c, and the point minus 5, 0 was on it. So we know that when we sub in minus 5, 4, we're going to get 0 equals 0. So let's do that. So y was 4 equals to m times minus 5 plus c. So then 4 is equal to minus 5m plus c. So let's get m on its own. So that's 5m equals c minus 4. M equals c minus 4 over 5. So now we have two equations, but we see we can get rid of the m if we let them equal to each other. So if this is equal to them and this is equal to m, then both of these are equal to each other. It kind of goes back to the same thing we were saying when y was equal to 3 plus 7x and y was equal to 4x plus 2, then we could let the y's equal to each other and let the whatever they equal to each other. So let's do that. Let's bring this here and this here and say c minus 4 over 5 is equal to 3 over 250 c squared. And so when these cancel, that's going to be c minus 4 is equal to 3 over 50 c squared. So that's going to be 3 over 50 c squared minus c plus 4 is going to be equal to 0. We can multiply everything by 50. And basically, when you factor this out, that's going to be... So when you factor that out, it's going to be 3c minus 20 and c minus 10. So when both these are equal to 0, we know that at least one of them is equal to 0. So c is going to be 20 over 3, or c is going to be 10. So same as before, when we have two things, we need to go back and check our m's. So m was equal to c minus 4 over 10. So m is going to be 20 over 3 minus 4 over 5. So that's going to be 20 over 3 minus 12 over 3 over 5 over 1. That's going to be 8 over 3 over 5 over 1. So that's going to be 8 over 15. And same up here, m is equal to c minus 4 over 5. So that's 10 minus 4 over 5. That's 6 over 5. So we have two values for c and m. So if c is 20 over 3, then m is going to be 8 over 15. And when c is equal to 10, m is going to be 6 over 5. So it doesn't really matter which we choose. Basically what this is doing is if this is our point E, it's going to be kind of steeper or not so steep, but the areas are still going to be the same. But it just says find the value of m and the value of c, where m and c are positive constants. So both of these are positive, and both of these are positive. So either one is a valid answer. So just choose one. Let's say we choose this one here. So when c is 20 over 3, m is 8 over 15. And that's that question done. So yeah, I'll leave it there. If you have any other questions, let me know. But other than that, I'll see you next week.